Alright, so today we'll go over this topic. I think you have already tried almost everything in the lab 10 and 11, but I think some of you don't realize it yet. So because I know we have some confusion about some of the programmings here. So remember, before we started 10 and 11, we had a lecture, and we now I think at least know why we need programming. So again, just a refresher. Let's say a very basic example. Let's say you don't want to solve an expression. You know the expression, you know the formula, you know the variables, you know the values. So you can always do that in the calculator. But how about if you want to do that for 10 times, 100 times, maybe 1 million times? It's not probably great. If you want to do it for 1 million times, you'll need a lot of time. You can do it for sure, but in a program you can just write a simple program of a couple of lines and that will do it for 1 million times. You know what I'm saying? So that's why we need the programming, because it's something like it's basically making your life easier. Okay, so all the boring jobs that you do, you can just transfer it to your program so that it just does the same thing for you. So we'll show you all the highlighting points here, which we want to cover from the lab 10 and 11. So at first we start C++. So this is the compiler we use. That was the last program we have written. Let's start a fresh one. So let's just start a new text edit or whatever, text project. Now let's say this is the first program. Now if you look at number 1, use of comment statements. So you can always write as many comments as you want. Now what might be the purpose of comments? First of all, comments are not read by the compiler. So if you write anything as comments, those will be ignored by the compiler. So why you want to do that? You still want to do that because sometimes you want to write some comments for anybody who will be looking at your code in future. Maybe even for you. For an example, let's say at this point you are writing maybe 30 lines or 40 lines. But in real program, when the people write it, for an example, when they write apps or some games or some programs like Microsoft Office, they write million lines. Okay. Now, when you are writing that many lines, you will even forget what you have written within a couple of weeks. You will probably not know why you defined some variables. You will probably forget why you had some equations like this. So that's why people try to write as many comments as they can, so that anytime they come back and they want to modify those programs, they can keep track of those. You can see every program that you use, maybe it's a free one or you bought it, they have some updates, right? You see, okay, new updates are available, then you update it. So how those updates are coming into the picture? Because they probably fix the bugs, right? They get the comments from the user and then they try to fix it, they write new codes. Now what happens when you have a million lines and you are trying to update it? Doesn't matter even if you are the one who have written it. Nobody can, memorize million lines. And if you write those million lines and within a month, you will even forget what you have written. So that's why it's really important to understand the importance of writing comments. We have also written the comments for you in almost all of the programs. You will see the comments. So in general, you can write comments in anywhere. So let's say you start the comments with a double slash like this. Okay. So let's say I just write this is a test program. So because I can write anything as a comment. Because this is just for somebody who will be looking at this program in future. Okay. But as long as we just give the backslash, double slash, then we are free to write anything after that point, all the way to that line. But if I want to write to the next line, I again start with the double slash. Okay. So, what is next? Next is let's start here. In general, in C++, we always write a function called main function. We can write plenty of other functions as well. We have not done it in any of our program, but in future, when you will be exposed to C++, you will notice there are plenty of other functions you can write. But the main function will be the only one function which will be always there. Doesn't matter how big your program is, doesn't matter what kind of C program you have written, doesn't matter how many other functions you have, you will always have one single function for sure, that is the main one. Okay? And that is the point where your compiler starts running the program. It may be at the very bottom. I'm saying, let's say you have 20 functions. One is the main function and other ones are some other functions. But you have written the main functions at the very bottom of your program. Still it will be the first one which will be looked at. Okay? So main function will be always there, and in C++, whenever you see those parentheses with anything, that means that's an indication that this is a function. And again, as a reminder, C++ is a case-sensitive language. So look at the main. We wrote everything in lowercase, right? We cannot change it. We cannot write M capital and then AIN. So because it will be something else. If you just write this, your program will not be able to identify it. Okay? So be careful. I'm not saying you have to do everything in lowercase. Whenever you are defining your own variable, let's say, be careful about the cases, okay? Because you can use uppercases there, but uppercase, something used as an uppercase, something used as a lowercase, they are different, okay? Because it's a case-sensitive language. And also, whenever you are trying to write a function, doesn't matter what it is, it may be main or something else, you always, what do? You just always put some braces like this, okay, to indicate the beginning and ending of the function. So whatever you will be writing in the middle, that will be part of main. Okay, because as I said, there might be other functions as well. Not right now, not in this case for our class, right? But in future for some other program. And let's try to see whether we can define some variables. You might notice that we can define different types of variables. One is, let's say, this is one of the most common one you use, right? INT, right? INT in short, it means integer. Now, integer means all the whole numbers of the world. Whole numbers, okay? It may be negative, but whole, like 10, 15, 16, 29. These are whole numbers, right? These are not fractions. But remember, they can be negative either, as well, okay? So it doesn't matter, they are negative, they can be negative, but they are whole numbers. So all those numbers are called integer. But did you notice one single thing here? Look at this. Whenever I have written INT, do you see that becomes bold? I did not make it bold. It was automatically identified as a keyword. Some of the things in C++ are keywords, okay? And whenever you type those, your compiler automatically identifies those as a keyword, and the color is changed. That's why INT, as soon as I type INT, let me show you something. Let's say I make it something else. You see the color was changed again? Because right now this is not a keyword, because it's INTX and your compiler doesn't know what it is. Okay? Now, let's say I define a variable. What can be the variable? Let's say I said person, okay? Remember, the person, if I write another variable, these two are two different variables. Can anyone tell me why? Because of the letter. You see the P in two variables. In one we use lowercase, other one we use the uppercase. Since we change the case, C++ is assuming they are two different independent variables. So you can either choose one or you can keep two, it's up to you. But you don't want to make it so confusing, because It's just a change of, so let's keep this one. Let's keep person. Okay, now, as I said, person, that means person here is a variable, right? And it can only take what? Whole numbers, maybe negative, maybe positive, but whole numbers, right? It cannot take fraction. Okay? It cannot take fraction. But for an example, let's say you want some fraction. What do you want? You can define the variable as a float. Float means all the fraction like 29.76. It may be negative, but fractions. I'm saying the decimal fraction, according to math, because fraction is people get confused. So decimal fraction stands for float, okay? But there are several other types. I'm just limiting my discussion within these types because I know that you have been exposed to only some of these, not all. There are several other types in C++. We are not covering everything, just a little bit from what we did in labs. Alright, so let's say I'm just trying to write a program where I will just ask the age of the person. Let's say, just to make it simple, I'll just ask the age of the people, okay, and then I'll average those. To be simple, I'm just trying to write a very basic program. You did much, I think, bigger program there, but I'm just trying to make sure that we understand it. Doesn't matter what it is, doesn't matter how small it is. We just want to make sure we understand it. Now let's say I define two variables, person and age. Remember, you can define variable later because a lot of times you start the program and then you come back and define it because you might not know how many variables you will need at the beginning. So you define something, you come back and define it. But remember, you must have to define it before you use. It doesn't have to be the first line. It can be in the middle somewhere, but it has to be before you use it. A lot of times you have seen it, right? You have seen like undefined variable, something like this, whenever you try to compile it because the compiler doesn't understand what you have written there. Because, let's say I wrote person, I wrote age. Compiler doesn't have any idea what does age means. What does person means? It just takes person as a word, which is a variable, and which can take only integer. It doesn't have any idea about what the person means because it doesn't have any idea of the semantic meaning of person, of age or age. So, but you might wonder why we are using person and age instead of using only x and y's, because we can just use the variable name at x or y. Those are simple and small. Anybody have any idea why? We can do x and y for sure, but still we want to make the variable's name as meaningful as possible. Why? Just for us, not for the compiler. Compiler doesn't care because it can be x, y, a, b, c, doesn't matter. But think about the program where you are writing a program and you have 100 different variables, and all the variables are like a1, a2, x1, x2, c1, c5. What happens? In future, nobody will have any clue what does x1 means. It's just a variable. They will not know exactly why you wrote x1. So that's why a lot of times you will see the professional programmers, they try to make the variable's name as meaningful as possible so that it relates to the program or the problem they are trying to solve using the program, so that you will know exactly what is the intention behind using that variable. But again, that's not required for your compiler. That's for you. Let's say when you calculated the gallons per paint needed, did you notice the variable name was so big, right? Gallons per what? Gallons needed something, right? For paint or whatever. But it was so big. It can be only G. But the reason we did that so that, there is a meaning behind, right? We know that the purpose is to calculate the gallons required to paint the whole room. So at least the variable name should represent something along that line. Alright. So What is next? Okay, now let's say in this program we'll be trying to take the age of the people and we'll average it. But we don't know how many people we'll have. We exactly don't know how many ages we will have. Look at the situation. We will keep it open as long as the user wants to enter the ages of the people. Okay, so they will enter the ages. Okay, and we'll just take the ages as long as they want. And then we'll continue. Once we are done, we'll just say, okay, you enter ages of this many person and the average is this. Okay, now let's see how we can do that. Now at the beginning, how you want to start? At the very beginning, you will do what? You will ask the age, right? You will ask the age of somebody, right? So let's say I'm trying to ask that. So to ask that, what do you need to do? You want to display something, right? Let's say you, remember, as I said, I'm not trying to write a professional program here. I'm just trying to write something which you all understand. Very basic one. Let's say I'm just trying to write something, enter age. Because, I first want to display it, right? I first want to display to the user, okay, enter age. That means what? I'm just giving the user a prompt where he can enter something. Remember, age has to be, do you want to make the age fraction? Let's make it fraction because, age can be fraction as well. It can be 25.6 for an example. Let's say, let's make the age fraction. Let's make it more precise. So it has to be float then, right? Age is a fraction right now. So it can, whenever it is fraction, decimal fraction, what happens? It can be whole number, it can be fraction, right? So let's make age fraction. So it is more precise right now. So we first say, okay, we first enter the age. So, and then we really want to take the age now. So let's write C in because you are taking the input, right? Now you are taking the age here. That is your age. You also want to sum all the age, right? I'm saying because you will have plenty of ages, 20, 25, whatever. So let's write another variable. This variable will be used to take the total ages. How many people will be entering age? It will be the total. So at the beginning, the total is what? 0. Because all the variables has to be initialized. Okay, let's make it 0 at the beginning because we don't know exactly. At the beginning, we start from 0, right? It's always true for that. Or maybe you can just write 0.0. It doesn't matter though. It doesn't matter. Now, the first person entered the age. So we entered the age for one person, right? So what do? You want to add that to the what? To the total? I'm saying to the sum. So let's do that. So there are two things happened here. To get the average, what do you need? In general, how do you make the average? What do you calculate the average? So you have to calculate the total of the ages, and also you have to keep track of how many person, I'm saying, how many ages you have taken. Basically, how many persons were involved there. Okay? So you have to keep track of person as well. Okay? Now let's say as I defined a variable called person, let's initialize with a 0 at the beginning. And at this point, because you now have taken one person's age, right? So what do you need? So what do you want? You can just add. Have you seen this in the program ++? Or maybe let's do it in a different way. We can I think we have seen this, right? We have seen this, right? Count equals to count plus 1. What did I do wrong in this line? I made a mistake here. What was that? Because look at the person, the variable start with a capital, right? Because as I said, this is a case sensitive. So the person should be, because otherwise the program will tell undefined variable. let's make it person like this. The reason I did that because we have taken the age of one person, so I just add 1 with the person, and also I want to calculate the total ages I got, right? So how do I do that? I'll just do sum of age equals to sum of age plus age. Now what I did here, I'm just adding the age I got. So this means what? See, again, don't assume it's a mathematical expression. What I did is this. Before this line, the value of the age was what? 0. So this is 0 right now. So I add 0 plus the age I got, and I assign this value to this. This equal mean assignment. So it's something like you had an old value and you add something with that, and then whatever the total you are assigning the total to the variable again. So basically you are adding some value and assigning it to something. Okay. So that is how we are keeping track of total age, and also we are keeping track of total person. We are taking the age. So that's the first person we took. Now, how can we keep track of multiple persons? This is the first person and we are done. Now how about the next persons? The only way we can do that is the loop. For an example, let's say we don't even know how many persons we will have. Let's say we might have 20%, we might have 15%, we might have 500%. Doesn't matter. How can you make it that? See, we just wrote those couple of lines only for one person. We cannot write like, we don't know exactly how many persons even will be there. So the only way to solve this problem is to make a loop. Okay, now let's make a while loop, because I think you have seen while loop and for loops, right? Let's make a while loop. I'll ask some question about the loop later. Just let's make the loop first. In while loop, we have to have a condition for the loop. And the condition is set because we want to run the loop if the condition is met. We don't know exactly what the condition will be at this point. Let's leave it open right now. I'll get back to this point. Now let's make a while loop. And again, as I said, we always start in. That means these are the braces for the while loop. Whatever inside these will be the loop. Will be the content of the loop. Now what do you want to do in the loop? See, you are done with the first age, but in the loop you want to take again the same lines will be repeated in the loop. So you want to maybe you can do this. Maybe let's see. Let's do this, because look at this, what I did. We first took the age of the first person, okay, and then we went inside the loop, and then we added that person, we added the age of the person, right, and then we are taking the next person, right, and this thing will keep repeating. Now if I don't write any condition, it will keep repeating forever. It will never stop. Meaning, we don't have any way to stop it. Now we must have to do something to stop it. Now let's make some condition like this. Let's say, just we just do it in our way. Let's say if we have somebody's age entered like 999, we'll stop there. How about that? Or more than 999. Okay, so how do you do that? What do you say? You will say while age is less than 999. What did I say? I said if age is less than 999, keep looping. That means what? Anytime if the age is entered 999 or larger, you will be out of the loop. So you will be done. And that age will not be added, because what we do is this. We first take the age, come here. If the age is more than 999, we just go, we even don't enter. If we're inside the loop, we take the age here and we go back to the beginning. We check first, right, whether we'll enter the loop or not. Now, if the age is more than 999, we do not even enter here. We do not add that person, and we do not even add the age. You see what I'm saying? So every time we are taking the age, and then we are first checking whether the age is 999 or larger. If it is larger, we don't add the person, we don't add the age. If it is lesser, we add the age, we take the total, and then we take the next person. Now, look at the idea behind. Now, just by writing a couple of lines like these, you can add million ages here. Because this loop will never stop if you don't enter anything 999 or larger. So what does it mean? You can just average the ages of 100,000 million people just by writing a simple program like this. You know, I'm just trying to show you the power of writing program, okay? Because we all know how to do the average of the people's age, right? I'm saying we all can do it just right away within a fingertip. But we cannot probably do the average of 100 people, like 1,000 people, maybe 1 million people. But this program can. Absolutely correctly, without any error. Now, in the loop, you have taken the person and you have also took the total. When you will be out of the loop, you want to display what? Average. Right? You want to display something, right? That, okay, what is the average? Okay, before I go out of the loop, let me just place a couple of, you know why we put /n, right? So that there are some blank lines between every time it is asking the age. So we entered that. Okay, now we are out of the loop. Now we will be showing the average and number of persons. We have taken the age. Now let's see. We want to display something. Okay, now let's see out. So we say okay, now total persons. How we know the total person? Because we just need to print the person, right? The variable person, because the variable person is always, you know, that has the total person, right? Is always added 1 whenever we got a new age, right? So that's our total person. And also you want to show what? Average, right? Let's show the average. How do you do the average here? Let's say I write average age. How do you get the average? You have the total age. You already added, right? You already added here. So all you need is just you have to write these and divide it by person. Because the sum of age has all the total of ages. Because every time you got a new age, you add it. Every time you got an age, you add it. Okay? And you know how many person there by the variable name is not right. It has to be capital S, capital P. So you should be done now. And also you just write a single function here. You always write get ch so that whatever the output, the string stays there. Okay? Because the get ch is something which waits for a single input of character. If you don't press anything, it will be just waiting for you. That means you will be showing everything, whatever is taken and what is the average and everything. So again, I just tried to write this program so that we also want to cover while loop to show you something. Now let's say you also have noticed that there are some header files we always try to include, right? There are some header files. Now let's include some header files, the ones that we always need. These are the generic header files. Remember, there are plenty of other header files as well. So it depends on what functions you are using. So the most of the functions that we use should be covered by these two header files. So let's run it and see whether we have any error here. So what is the error here? Okay. Now, so we are entering the first age here. I'm just entering age as much as I can. I should not go that far, so. Remember, anytime I enter something 999 or larger, it will stop. So let's stop it. Let's enter 1000. It stopped. Look at this. It said you entered 21 ages and the average is 50.83. We can do the same math, but not that fast, right? And it will never stop. You just entered 21. You could have entered 100, 1000, doesn't matter. Okay, that's a simple program we did, right? Now, let me go back to the program again and let's observe a couple of important things here. Now, look at the loop here. We used while loop. We had another loop as well, like for loop. Okay. Do you have any idea why we choose while over for? We could have used for here, right? There is one problem with the for loop. The for loop runs for a specific number of times, and you have to define it. You have to say, okay, run for 10 times. Run from here to here, okay? You say, okay, run for the value of I is 1 to value of I is 10. And every time the value of I is increasing by 1. That means it will be running for 10 times only. You see what I'm saying? But in this case, we did not know that how many ages we will have. Look at the difference. I'm just trying to bring this point because I just wanted to make sure you understand what are the purposes of different loops here. The for loop runs only for a specific number of time you mentioned. But the while loops runs only on the condition. As long as the condition is met, it will keep running. Now, in this case, while loop was the best one because we did not know how many ages we might be having. We might have like 20 ages, 200 ages, 500 ages, right? We did not know that. So that's why it kept running. So this purpose, the while loop was the best choice. Okay? Alright, so we pretty much talked about most of this. And also, just in case, instead of /n, you can also use and l, right? For an example here, you could have used and l. There will be space between that line and the next line, right? And also look at a couple of things like some tests, because sometimes we want to test something, right? Like x equals, for an example, you did like some kind of number test. If x equals to x bigger than these, x is smaller than these, what do? Okay, we do it using if else, right? So for an example, let's say I add some lines here. Let's say I add if this is our average, right? This is the average, and if I say this is greater than, let's say this is smaller than 50, if this is smaller than 50, then I say average is too low. Or if not, I would say average is fine. You see what I'm saying? So now you see, we can also test some condition like this. If the average is this, I said, oh, average is too low. So you can always use this. If you check, there are some negative number testing. Now, how you check one number is negative or not? If you say, okay, can I check? So let's say if somebody said, can you check whether this number is negative? How do you check it? If you just compare that number with 0 and say if x is smaller than 0, that means what? If it is true, then number is negative, right? If not, number is positive. Okay. And also make sure you check check the back side, question number 11. See whether you understand the output of the program. Alright, so if I go to this program, see, the reason we gave you this because we wanted to show you that you might see some question like this where a segment of the program will be given and you will be asked to tell us what will be the output of the program, okay? Now, if you look at this one, what we did here, at the beginning we defined a variable called size. This is a float variable and the value is 15.5 at the beginning. And then we did an if-else loop. We said if size is greater than 10, we do something, or otherwise we'll do something else. Now tell me which will be true. I'm saying when you have if and else, there are conditions, right? Which condition is true? Is the size is greater than 10? Size is greater than 10, right? Because the value of the size is what? 15.5. So this part of the code will be running, right? This part will not be running because it's not true. Because, when you have if else, that means what? Either this is true or that is true. So both cannot be true. Either one is true. Now the first one is true since size is greater than 10. Because look at the value of the size at the beginning. We assigned 15.5. So the value of the size is 15.5. So this part will be running and this line will be printed. So it will be printed like size equals to 15.5. And the next line will be what? Size accepted. So that's what we have shown you here. Now let's say if the value of the size is 5, then what happens? Then this part will not be running, right? Because right now the size is not greater than 10, it's less than 10. So this part will be running. So at that time what will happen? You will see size equals to 5. Size not accepted. Okay? Just to identify what will be the output of a small segment of program. Look at the program and see whether you have any question. Let me make it a little bit enlarged. I think you can see it on your see whether you have any question here. This is an example, okay? You might see something like this. And also remember, you did a lot of programs, because for 10 and 11, there are plenty of codes you have written. But make sure you must look at some of these because you have to write a program there as well. Okay? So you have to write the code for the program, which might be similar to this. And as always, you have to turn in the program with the output. We know the output, right? The black screen, but don't just give the snapshot of the output. You know how to copy the output, right? There is a printing method, so you copy it and paste it with the program as a command line, just how you did in the program, lab 10 and 11. Then you again, don't turn it to me. You can turn it to there in the part 3 this time. In the part 3, the part 3 is the one where you do it manually, okay, something. But this time in the part 3 there will be text boxes. Okay, so don't turn the paperwork. All you need to do is just put the program or whatever you want to, just put it inside the text box and submit it. But it will not be graded right away because I have to look at it as just a manual grading, okay? So you will not see the grade. When you submit, the grade will be 0. So don't worry, manually it will be added. Okay. Any other question? See, we all tried to do a small program because I wanted to make sure we did much bigger program as well. But sometimes I really wonder whether we understood those. So that's why I tried to do a very small one and wanted to show you something about what a programming really can do. What is the power of that? Look at the age calculation. You can always do that, but can you do it for 100 people, 1,000 people, million people? Not really, right? Or even if you do that, it will take a lot of time. But a simple program like this, not too long, it's not worth at the beginning because you are spending too much time just calculating the age of 1 or 2 or 5 people. But it's worth when you are calculating the average of like 500 people every day. Because once you write it, that's you are done. You can just run the same program again and again for doing the same stuff. Any other question? We know the date of the test, right? That's just December 10, but the time is different. It's 9:45, not 10:45, okay? Be careful about the time. I also mentioned and I highlighted the time because it's a different. It will be 2 hours. There will be 3 sections just like the other test, okay? And one more reminder, there were 2 bonus parts. Do you remember there was some bonus part on the hardware lab we did? I think some of you still did not complete those labs. It's your bonus. Now it's up to you whether you want those or not. All the bonuses will be added to the final. So make sure you finish your bonus. There are 2 chances for those bonus. If you have not done it or if you even submitted but your grade is not good, you still can take another chance. There are 2 chances. If you do it, that will be your bonus added to the final. It's already there, the hardware software quiz. The bonus was on the lab 7 and 8. Remember we built the computer and also we did the software installation. The bonus was on that. I think most of you did, but not all. And there is also one more bonus on the yeah. So make sure once you sign up, you click there is a link inside the email. If you don't click the link, I don't know exactly whether you have done it or not. Once you click it, there is a mail come to me, then I'll know exactly what you did and I give you the bonus.
Which time? It's December 10.
Yeah, it's on the class time. That's the this is the time, yeah.
Okay.
That's our class time, right? I'm saying the class is starting from between. It's pretty much, it's still the same time. Oh, I'm sorry, this is the time. This one.
Okay.
Yeah. See, we are just going by the schedule, so as it was. Any other question? If you have submitted your, I think I have some of the labs. Let me see. Okay, let's stop the presentation here. So let's see.